Good morning, everyone. Am I audible?
Yes, sir.
Okay. Are you ready with your presentation?
Yes, sir.
Okay. Who is going to present first? Who is going to present first? So every time I have to announce the name from your side, nobody will come. कभी तो अपने आप से आओ. किस किस को दिया था? अंकुमनी, then नेहा, then जितुल, उसके बाद साइदुल and और कौन था? Oh, four को दिया. Only four students. अंकुमनी, नेहा, जितुल and साइदुल, I think. Yes.
Sir.
There are four topics. The okay, one boy, one girl. Let's start with the ladies. Ladies first. Let's use the concept of ladies first. So let's start with Ankumani.
Okay, sir.
Okay, all the best.
Good morning, everyone. This is my first presentation given by Prasanna sir, and I have submitted to you also.
Yes, I
And
got it.
my topic was, yeah, sir. My topic was on hierarchical database model. It is a part of data model, and my name is Onkumani Doyamari. Good morning, everyone. Okay, I'll start it.
Okay,
Sir, the definition is given here.
you decrease the zoom, okay, and you click the play, then it will come one by one slide at a time. There's a play button, I think. One play button is
Yeah.
there. Yeah, this one. You click the play button.
Okay. Next page. How does it come?
You slide. You slide it.
Okay, this is the definition. Thank you for the help, sir.
Okay, welcome.
Okay, sir, I'll have to explain now.
Yes, you start. You have to explain.
Hierarchical data model. It is a data model in which data is represented in the tree-like structure. In this model, data is stored in the form of records, which are the collection of fields. The records are connected through link, and the type of record tells which field is connected by the record, and each field can contain only one value. It means that this is the diagram. A1 is the root node, and in hierarchical model, we represent data in the form of trees. And A1 is the root node, sir. Then this is the kind of structure, how this is the way files work. And B1 and B2 are the child of A1, and C1, C2, C3, C4, up to C5. These are the child of B2 and rest like that. And it represents hierarchical database. It represents one to many relationships efficiently. And it is difficult to improve because of the vastness of this tree. And okay, this diagram, this model is not so sorry. This model is not so flexible because when we try to add something new, we have to the whole diagram gets changed. Then the third point is that developing an application on this kind of model is difficult because the programmer has to remember everything from where it
Ankumani,
comes.
you seen the slide. The slide is in definition, and you are discussing about advantages and disadvantages. So, okay, what whatever whatever the slide you are presenting, you have to explain accordingly. Okay, because whatever you are explaining, we are related to the slide. Okay, once you explain about the definition, then you highlight your definition slide. Then if when you go for advantages, highlight these, then the disadvantages accordingly. Okay, and whenever you use a whenever you use a diagram, in the lower section of the diagram you have to mention figure 1. What is this figure? Okay, so accordingly you have to do that. Okay, continue, change the slide and continue.
And so we can say feature here we store data in the form of hierarchy of data. Then parent and child relationship it must have. Then we use pointer. Then because already data are saved, that's why disk input and output is minimized. Then it's fast in navigation and it has predefined relationships. Next topic is usefulness. Yeah, previously it was used during the macro computers era, and nowadays, yeah, previously mainframe computer era, previously it was used, and nowadays it is used in geographical information, then for storing file systems. It is used in applications where high performance is required, such as telecommunications or banking. And we have two criterias or two parameters. Uh, we use this when we these two conditions are met. This two mentioned conditions. Then the advantages are data retrieval. Its advantages are data retrieval. Data retrieval means obtaining a data without ambiguity, and referential integrity. It means referential. It is a property of sharing data in in reference valid in valid references, and it keeps data safe from being corrupted, and it is efficient in 1:n relationships or 1:many relationships. And the result we get by applying this model are clear. Uh, Disadvantages. Uh, in disadvantages, addition of new entry or data is difficult because when we want to add something in the parent, in the child nodes, or in a long place, then with the whole diagram, the whole figure gets changed. That is why it is difficult to add a new addition. Then redundancy, it means that we have to uh, add so many data along with the unnecessary data. This is the data redundancy. Then many to many relationships are not supported because of the restrictions we have in tree diagrams or properties. And communication barriers, because the child nodes are not connected with each other, it is difficult for communication. Then this is an example where a student can take many courses, but many courses cannot have one student. Sorry, a course can have many students. This is the diagram, and here this is the student ID. We are using linked list. This is the code, subject code, and enroll subject ID. Sorry, student ID, student name, student age, and this is the course ID and course name. And from this hierarchical database model, we can transfer it to relational tables also. This is the way how we can represent a hierarchical model. in relational model. This is the conclusion. Thank you.
Thank you, Unkumani. Okay, it was a nice presentation. Can you tell me a real time application of hierarchical database model from whatever you have gone through? So can you tell me that in this particular area or in these circumstances, we can use a hierarchical database model in a real time, which is related to our real time activities?
Banking.
Yes.
In telecommunications and banking systems,
How can you explain?
uh, like a person can uh, have a bank account and he or she can do multiple transactions while the transactions can be assumed as child.
The transaction can be
And
assumed as side. Anyone
yes, sir.
else? Anyone else who can give an example? Because this is not only for a presentation for Ankumani. You can also go for it. Can anyone tell me? Anyone else? Or do you have any query? You can also share here. Any query? No one. Okay. The next Saidur.
So actually, so I'm making the slides right now, so I'll go to class.
What?
So I'm making the slides now, so I'll go to class. Go to class.
Why? Why you are making the slides right now? Saidur?
Listen.
Why you are making the slides right now? What you have done till 11 a.m. then from yesterday?
Also, actually, this thing is object-oriented, but it's a complex thing. So
Don't give me any excuse, okay? Don't give me any such kinds of excuses. I told you clearly. I told everyone that you have to prepare 2 to 3 slides maximum. And you are telling that you are preparing the slides right now. If you are not taking the instruction seriously, at the end of the semester, you will get suffer. I'm telling you. I'm taking extra classes so that the concepts can be cleared. You will get more time to go through these topics. Next, Neha. Neha, are you there? Hello, Neha.
Yes, sir.
You start. And if someone gives such kinds of excuses later, be ready for the punishment. It will be clear from my side. I expect each and everyone to take each and every instruction seriously. It's not for myself. It is for your betterment of your career. You have to take it seriously. If any faculty give you some assignments, you have to do it on time. Don't give any kind of excuses. Otherwise, at the end of the day, you will get suffer. Okay, Neha, you please start.
ওলাব পৰা নাই ৰখক অলপমান ৰখক।
Okay. You click the share button. মোবাইলৰ পৰা ইউজ কৰি আছা নে তুমি?
মোবাইলৰ পৰা ইউজ কৰি আছো।
শ্বেয়াৰটো ক্লিক কৰা।
শ্বেয়াৰ কণ্টেণ্টটো যোনটো আছে
না না শ্বেয়াৰ বাটনটো যে আছে, শ্বেয়াৰ বাটনটো সেইটো ক্লিক কৰা।
গুগল ড্ৰাইভত আছে।
তুমি শ্বেয়াৰটো ক্লিক কৰা। শ্বেয়াৰটো ক্লিক কৰি য'ত আছে তুমি তালৈকে যোৱা। And everyone do one or two practice on sometimes how to share this content. Okay, at least being a computer science guy, you should know these things. So among yourself, you try how to share the content. Okay, so if you're facing difficulties, so you share the content with suppose Ankumani or someone else who is familiar with this system, that he or she can share the PPT, because we have a limited time, 50 minutes time. Okay, yes, it's coming. Saying content. A relational data model. Yes, you continue.
বাকীখিনি অহা নাই, লাহে লাহে আহি আছে।
আহিব. It will take some time.
দেখা পাইছে?
Yes. I think you also have a play button. আছেনে play button এটা?
ষ্টপহে দেখা পাইছো।
ঠিক আছে, হ'ব দিয়া, তুমি এনেকৈ কৰা, এনেকৈ দিয়া। নেক্সট টাইমৰ পৰা অলপ প্ৰেক্টিচ কৰি ল'বা দেই।
Sir, good morning, sir. My topic is relational database model. This is the definition here. The relational database model is the most common model in industry today, as relational database is based on the relational model developed by EF Ford. A relational database allows the definitions of data structure, storage and retrieval operations and integrity constraints. In such a database, the data and relations between them are organized into tables. A table is a collection of records, and each record in a table contains the same field. Here, the database is a set of related relations. Each relation has a name which indicates which type of peoples the relations has. For example, a relation's name student indicates that it has student entities in it. Each relation has a set of attributes which represent what type of information the entities or tuples have. For example, student relation has a set of attributes, roll number, name, department. It indicates that the student relations has student entities that have information about their roll number, department, and name. A tuple A tuple in a relation is a real-world entity. It has a set of values for corresponding attributes. Each data value in a row or tuple is called field. Next is characteristics. Characteristics of relational database models are
Each relation in a database must have a distinct or unique name, which would separate it from the other relations in a database. A relation must not have two attributes with the same name. Each attribute must have a distinct name. Duplicate tuples must not be present in a relation. Each tuple must have exactly one data value for an attribute. Next, tuple in a relation do not have to follow a significant order as the relation is not order sensitive. Next, similarly, the attributes of a relation also do not have to follow certain ordering. It's up to the developer to decide the ordering of attributes. Next, advantages and disadvantages in relational data models. First is simplicity. Simplicity, a relational data model is simpler than the hierarchical and network model. The next, easy to use. In it is easy as table consists of rows and columns, is quite natural and simple to understand. Next, structural independence. The relational database is only concerned with data and not with the structure. This can improve the performance of the model. And last, data independency. The structure of a data can be changed without having to change any application. Next is disadvantages. Disadvantages, first one, cost. Here, one disadvantage of relational database is the expensive of setting up and maintaining the database system. Next is abundance of information. Here, advance in the complexity of information cause another drawback of relational database. Relational databases are made for organizing data by common characters like image design, multimedia products, and complex numbers. It's easily categorize the way for a new type of database. The next is structures limits. Some relational databases have limit or field length. When you design the database, you have to simplify the amount of data. Specify the amount of data you can fit into a field. Some names or such queries are shorter than the actual, and this can lead to lost data. And the last is isolated databases. This database becoming island of information, where the information cannot be shared easily from one large system to another. Next is the example. Here the figure below indicates the relation in a relational model. It is a student relations in relation. This is a student relations in relation model. It is a relation and it is having entries of students to it. The next diagram, here we can understand the relations, attributes, tuple, and field in a relational model. And the last is conclusion. In a relational model, real-world objects are represented in tables. Tables can grow large and have multitude of columns and records. Each table is made out of rows and columns. Each row, also known as tuple or record is made out of fields, also known as attributes. Each attribute stands for a certain features of the real-world object, and attribute is defined by a name and its value. And so this is all about the relational data model. Today it is widely used to design the database system, and majority of database systems today are constructed using the relational database model. Thank you.
Okay, thank you, Neha. It's a nice presentation. So whenever you go through the relational database model, from your point of view, what is the more useful advantages of relational database model over the others? Because you have mentioned, suppose go to the advantages page, go back to the advantages slide. Okay, simplicity, easy to use, structural independence, and data independence. So, from your point of view, what is the most uh, useful advantages of relational model?
So it is easy to use.
Easy to use.
Mm.
So,
And one of the most one is data independency, because whenever we want to make a change, then we don't have to change the application. We can insert anything we can do, like insertion, insert, then delete, or we can modify anything by without changing application.
okay, okay. Anyone else? Any query from anyone?
Is it because of the structure that we represent in tabular from row and columns?
Yes, Ankumani, please repeat.
So I mean that advantage, the best advantage is that we are able to represent many things in row and column in single
Yes,
table
yes.
in different way.
Next, Jitul.
So hi everyone, my topic for today's presentation is network database model. Hello.
Yes, you are audible.
Sorry,
Yes, yes, you are
okay,
audible. You continue.
okay. Let me quickly go through the contents of my presentation. Uh, Firstly, I will be discussing the history of network database model. Then I'll be going through the differences of hierarchical database versus network database. Then I'll be discussing about what is hierarchy, and then what is network database model, and then advantages, and lastly disadvantages. So let's get started. So network database model. So network database model was invented by Charles Beckman in 1969 as an enhancement of the already existing hierarchical database model. Because hierarchical database model was full of flaws, Beckman decided to create a database that is similar to the hierarchical database, but with more flexibility and less defaults. The original and existing hierarchical database has one owner file linked strictly to one member file, creating a ladder effect that restricted the database to find relationships outside of its category. So what's ladder effect? It's the data redundancy across the database. And as we already know, redundancy means duplication of database. We will see this in a later example through the presentation. So hierarchical database and network database. So in hierarchical database, we have one-to-many relationship. But in network database, we have many-to-many relationship. Hierarchical database is difficult to navigate because of its strict owner-to-member connection. But in network database, it's easily accessed because of the linkage between the information. In hierarchical database, less flexibility with the collection of information because of the hierarchical position of files. But in network database, great flexibility among the information files because of the multiple relationships among the files. We will see this in a later example. So what hierarchy? Let's take this database example of school. Let's say we have this database school in which this school object is the parent table. Then under school, we will have different tables like students and teachers. And these two tables, students and teachers, are the child tables of this parent school table. Under students, we have different entities like name, age, class, and on the other side, in teachers table, we will have another entities like subject, name, and salary of the teachers. So this is the hierarchical form that are maintained in a hierarchical database. So let's say suppose we want to know the name of the teacher and the address of the teacher who is assigned to class 5 for the English subject, then we have to go to the students table. Then from the students table, the parent table, school will be gone. Then from there we will search the teachers table, and from the teachers table itself we will search the particular name of the table, and then we will get to know his address. So this is the hierarchy, means we have to go from child to parent, then again from parent to child to search for a particular data. So in comparison to hierarchy, how network data model works, we will see in the upcoming slides. So network data, nothing but an upside down tree where the branches are the member information linked to owner, which is the bottom of the tree. This database model allows multiple records to be linked to the same owner file. This multiple linkage allows it to be very flexible. Relationships in the network database model is defined as many-to-many relationship because one owner file can be linked to many member files and vice versa. So as talking about network database model, this is an example of network database model. So how it works? Let's say we have a sales database. So in sales database, there will be many tables like product, invoice, and payment. So a customer will buy a product for which he will make payment, and for payment he will have we will be storing the payment information, which will also be linked to the invoice table or invoice section, which can be accessed and updated by the salesperson. The invoice part will be directly linked to the main invoice line, which contains the list of products that is sold or unsold, and this will also be linked to the product table. So this is how a typical network database model looks like. So let me go through the database model. Previously seen, it has many-to-many relationship. This type of database can be easily accessed in any table record in the database. For complex data, it is easy to use it because of the multiple relationship found among its data. Easier to navigate and search for information because of its flexibility. So let's say suppose we want to find details about a particular invoice made by a particular customer and his payment details also. So as we can see here, the customer table is directly linked with the invoice table and the payment table, so we can easily grab and find out the details from these tables. Network database model. So it's a bit difficult for the first time users, and difficulties with alternations of the database because ways information entered can alter the entire database. The customer has made some payment which is updated in this payments table, but because of some issue or hardware failures or some software issue, the invoice table is not updated. So in that case, we may have a data in database model. Thank you.
Okay, Jitul, it is a nice presentation. So my question is to
Thank you,
you.
sir.
Okay, so just explain a real time example of your relational database model and how you can say that
Sir,
it is one of the best or it is more beneficial among all the other database model.
Sir, it's not beneficial among all the other,
Yes.
but it is better than the hierarchical because in hierarchy we have to go from child to parent, then again parent to child to search for a particular set of data. But in network database model, as we have links together, like as I have shown in the customer example. So in customer table, they have made payment and for which we have another table invoices. So if we want to extract the details of payment and invoice, because these two tables are directly linked to the customer table, we can grab that. But it still lacks some functionalities as compared to the relational database, which is out of discussion of this presentation.
Okay. So in hierarchical, as Ankumani mentioned, it is basically one to many relationship.
Yes, sir.
Okay. But in your case, what will be the possible relationship or cardinality ratio among the entities? Suppose
So
if we
it can be
consider
one to so it can be one to many or many to many.
many to many. Okay. Good. Anyone else? Anyone have any query? Okay. Next, Saidur, did you complete the slides?
Yes, yes.
Okay, start. You don't have so much time. You be quick.
So is it visible, sir? Hello, sir. Yes, sir. Hello. Is it visible, sir? Hello.
Saidur, you start.
Yes, sir. Yes, sir. Is it visible, sir? So my screen is
Yes,
visible.
yes, it is visible. You start.
Alright, sir. Alright, sir. Actually, yeah, my name is Saidu Sheikh and I'm explaining object-oriented database in a very short time actually. So,
Your voice is not.
now,
Your voice is not clear.
so actually maybe I have some
It's breaking.
this,
You can do one thing. You record your video and share in a group. If your network is not good, so you record your presentation with your and you can share in a group, official group, because the meeting will
so
end
now
in
it's
5 minutes. No, your voice is not
okay,
clear. You use any screen recorder and do the recording of your presentation and kindly share it in a WhatsApp group or you can mail me also. Because your voice is not clear. Whatever you have explained, it is not clearly audible to me. Okay, is it okay to you?
Yes, sir. Yes, sir. Yes, sir.
Okay, by 1 o'clock I need your video. You have 1 hour. Okay, you share your presentation video in the official groups, that so that everyone can go through it. Okay, after 1 p.m. I will not accept your presentation. Before 1 p.m. I need your presentation video.
All right, sir.
Okay, thank you everyone. So we'll continue in the next class.